All right, good morning. So the directions are on the screen. Today you're going to do your warm up and go over the video and take notes on that. That's going to be one part of your grade, and then the other part will be submitting your Bitly assignment like we normally do. I also, next to each part, put about how long it should take you. So the video to do the warm up and to watch the warm up should take you about 10 minutes. To take your notes and watch the rest of the video should take you around 15 minutes. And then to do today's assignment should take you between 20 and 25 minutes. So again, you'll be graded on the first two paired together, and then number three as it is, just like we normally are. So today's warm up is on my screen. I told you should take about 7 or 8 minutes to do it. So right now, I want you to pause the video, do your warm up. When you're done your warm up, or you want to go over the answers, unpause the video and make sure you write down everything and check your work. If you have any questions, remember you can still come to me and get help as I pull small groups. So pause the video at this point and go ahead and do your warm-up. Okay, going over the warm-up. So here we go. Number one, we had an 8-hour shift and the employee was able to assemble 12 3/4 engines. So right there, this sentence, the first sentence is going to give me my ticket. I'm comparing hours to engines. So in the first sentence, they talk about being able to do in an 8-hour shift, 12 3/4 engines. The question wants to know if we had 40 hours, how many engines would the employee be able to put together? So we cross multiply, we'll do 8 times x, which gave us the 8x. And then I did 12 3/4 times 40 in my Desmos calculator. So again, if you're unsure, all we got to do is hit 12 3/4 and then multiply. And we're going to multiply it by 40, and we should get 510. So again, there's my first part. Let me minimize that. Now I have to divide each side by 8. So I'm doing 510 divided by 8, and you should have gotten an answer of 63.75. If you got the fraction answer, okay, 63.75, and we wanted it as a fraction, remember all we have to do is hit that little fraction to decimal button and it would convert it to 255 over 4. So either answer is acceptable, either the 255 over 4 or 63.75. Moving on to number 2, Mike had a basketball for a total price of $15.50. He had to pay us 15% sales tax. How much did he pay in all? So the first thing I wanted to find out is what is 15% of $15.50? Right here, that gives me my tax. So now I know how much tax to apply to my bill. Tax is an additional fee, so I had to take the original price, $15.50, and add my tax, $2.32, to get a final total of $17.82 total. Number 3, what we've been working on this week and for the last couple of weeks, I'm going to drop down the -4a and the +2b because they are not touching the parentheses and they're not inside the parentheses. So that means that I'm going to over under this -2 times +a to give me -2a, and then -2 times +4b to give me this -8b. From there, I combine my like terms. I know that -4 minus 2 in my Desmos calculator says -6, and that 2 minus 8 is also -6b. So your final answer, both parts of the term should have been -6, -6a, and -6b. The order does not matter. And then today's number 4 is a little bit different than yesterday's number 4. We're determining the total area this time. So the first thing I wanted to start off was my 2 area formulas, area of a circle and area of a rectangle, since that's the 2 shapes I'm dealing with. I'll do the circle first. This diameter line lets me know that I have a diameter of 4, therefore the radius would be 2. I know that my area formula is equal to pi times the radius to the 2nd power. But since I have a semicircle, I also need to divide that by 2. And the cool thing is I can put that all in my calculator all at one time and not even get the trap answer. So in my Desmos calculator, I did pi 2 to the 2nd power divided by 2. If you needed me to show you how to put that in your calculator, we hit pi, the radius to the 2nd power, and then the whole thing is going to end up being divided by 2. Oop, and I actually forgot to hit the fraction bar first. So I'm going to put pi 2 to the 2nd power and then scroll down to the bottom and put divide by 2. And that's where I got my 6.28. Okay, I left it as just 6 since we're dealing with a rectangle. So that's only the first part. So far, I found the area of this top piece to be 6. I also had to find the area of the bottom piece that I did in blue. Obviously, we can see the answer is 32, but how did I get 32? Well, the area of a rectangle is equal to length times width. So the length and the width were 4 and 8. 4 times 8 is 32. So now I have to combine my areas. I had my first area of 6. And now I'm combining that with my rectangle's area, 32. 32 plus 6 would give you 38. So again, it's up to you to make any corrections on your warm-up, and I will come around and grade those as we get going here today. So as far as today's lesson, we're going to be learning something new. We are moving into solving equations and inequalities. This slide right here definitely needs to go into your notes. We have 3 things that we need to look at when we're solving equations and inequalities. We're going to be spending a lot of times on equations, things that have an equal sign, but these rules also apply to inequalities, problems that have less than, greater than, or equal to. So our number 1 goal is to isolate the variable. Remember, a variable is an unknown number that we are representing with a variable. So our goal, when we say isolate, we're trying to get that variable by itself. The golden rule is whatever you do to one side of an equation, you have to do the exact same thing to the other side. And then anytime we're solving equations, we're basically working backwards to find the answer. We're using inverse operations. And if you don't know what the word inverse means, it's a synonym for the word opposite. So if their problem has an addition problem, we're going to be using subtraction to solve it. If the problem is a multiplication problem, we're going to use division to solve it. So we're going to use our opposite operations. So if you don't know what your opposite operations are, adding and subtracting are opposites, and then multiplying and division are opposites to each other. And get this into your notes, and then we're going to do a bunch of examples and definitely get some of these to try. Now, you've done these problems in 6th grade. The only difference between the 6th grade problems and the ones we're going to start off in 7th grade is some of these problems are going to have negatives. Last year, everything you did was a positive and with a positive answer. So here we go. First example, okay? This is going to be similar to what your work is. You actually don't have to write down this example, but your work's going to look like this. This problem is x plus 12 equals 25. And notice I subtracted by 12 on both sides. I used that inverse or opposite operation. Whatever I did to one side of my equation, I did the same thing to my other side. And the reason why I did that is if I have 12 and I take away 12, I really am left with just x on that side. And then again, whatever I did to one side to get rid of that plus 12, I have to do to the other side to get my answer. And this kind of makes sense because I know that 13 plus 12 is the only way to make 25. If I have something plus 12 equals 25, the only thing x could be is 13, but we just proved that mathematically. So some of these problems you might come across today, you might be able to do mentally, but the key is to learn how to solve them, because once we get to what are called 2-step equations next week, a lot of these problems you're not going to be able to do in your head. Or if there's fractions and decimals and negatives, we definitely want to know how to solve it mathematically. So here's our first 2 examples. I'm going to do the one on the left first, and then we'll get into this one on the right. So let me make this example a little bit bigger. Now, the first thing we want to do when we're solving these problems is help set up the problem. We want to kind of keep our work nice, neat, and organized. This first problem says 12 is equal to x plus 32. Always when I start off, I want to find the middle of my equation. The middle of my equation is my equal sign. That lets me know that where my left side and my right side are. I also want to find the variable. And what I usually tell students to do is put a box or a circle around the variable. That way you know what side it's on. On this equation, the variable is on the right side. So I have to get rid of anything else that's on the right side and get that variable all by itself. Well, what's being done to that variable on that right side is it's being added by 32. Well, I know that the opposite or inverse operation of adding 32 would be to subtract 32. And when we talked about the golden rule, whatever we do to one side of our equation, we have to do the exact same thing to the other side. Now, our whole goal is to get one part of that equation to go away. 32 minus 32, it makes 0. So all we're left with on that right side is x. And remember, our goal was ultimately to get x by itself. And then all I need to do is go into my Desmos calculator and do 12, take away 32, and my calculator is going to say negative 20. And that would be the correct answer. Okay, second example, I'm just going to scroll it down here. If you need to pause the video at any point, remember you can do so. So second example, now I have x plus 21 is equal to negative 19. So again, the first thing I'm going to do is break this problem into a left side and a right side through the equal sign. The equal sign is always the middle of the problem. Then I'm going to locate my variable. My variable is over here on the left side of that line. What's being done to that variable? Well, it's being added by 21. Well, I know that the inverse or opposite operation of adding 21 is to take away 21 or subtract 21. And again, whatever I do to one side, I have to do to the other side. The side with the same number and opposite operations gets canceled out because 21 minus 21 is 0, leaves us with just x by itself, which is our goal to get the variable by itself or to isolate it. And then again, I would go into my Desmos calculator and I'm going to type exactly what I wrote. Negative 19 minus 21 would be equal to negative 40. Okay, so make sure you have those two examples. At this point, I want you to take roughly the next 5 minutes. If it doesn't take you 5 minutes, that's okay. Okay, so pause the video now. I want you to try these 4 on your own. If you still need a little help and you want to see an extra example, like maybe you want me to try the first one and then you try the next 3, that's okay too. So if you need more examples, don't pause the video and I'm going to go over the first one. So here we go. The first one. Again, I'm going to break it into a left side and a right side. I'm going to locate my variable n on the left side. What's being done to n? It's being added by 11. So I know that the opposite or inverse operation of plus 11 is to subtract 11. The 11s will go away, leave me with just n on the left side, which is my goal. And then in my Desmos calculator, I would do negative 32 minus 11, and it's going to say negative 43. So again, if you needed an extra example, now you have 3 great examples, and you should try the next 3. If you're already ready for me to go over them, I'm going to keep on going. So the second example, we'll do the top right. Now I have 15 is equal to b plus 19. So here's my variable b. It's on the right side. Remember, it doesn't matter what side it is. We're always going to do the inverse or opposite operation to that side. What's being done to that variable b? It's being added by 19, so I need to take 19 away from both sides. My 19s go away. I drop down my b. And then again, in my calculator, I'll do 15 minus 19, which is going to give me negative 4. So you should have got negative 4 for that one. For the bottom 2, same thing applies. It doesn't matter if we have decimals, fractions, whole numbers, positives, negatives, everything stays the same. So again, I'm going to break my problem into a left side and a right side through the middle of the equation. I'm going to locate my variable x. I'm going to think about what's being done to my variable. It's being added by 1.5, so I need to subtract 1.5. The 1.5s will cancel out and leave me with just x by itself. And then in my calculator, I would do negative 4.5 minus 1.5, and my calculator would say negative 6. And then my final example here. Okay, again, I'm going to break it into a left side, right side through the equation. I'm going to find my variable m. It's on the right side. What's being done to m is it's being added by 11, so I need to subtract both sides by 11 to get rid of that plus 11. I drop down my variable, m by itself. Great, that's my goal. And then in my calculator, I would do negative 9 minus 11, and negative 9 minus 11 is going to be equal to negative 20. So I'll scroll back up so you can see all 4 problems together in case you missed one. If you got to pause and go back through. If you have any questions, raise your hand. I'd love to help you. Okay, moving on. We're also going to do some subtraction equations. The same thing. If I had a problem like n minus 15 equals negative 38, well, again, notice how I broke the problem into a left side and a right side. I'm going to locate my variable. There's my variable n. What's being done to that variable? It's being subtracted by 15. And again, I know that my inverse or opposite operation of subtracting 15 is to add 15. Whatever I do to one side, I do to the other. In my calculator, negative 38 plus 15 equals negative 23. Like I said, that's just one example. If you want to pause the video and put that one in your notes, or if you want to just follow along with me with the next two, that's okay as well. So again, just like I did with adding, I'm going to do two examples with subtraction and then give you a couple to try on your own. So same thing applies. We always find the middle of our equation. We locate our variable. In this case, it is v minus 12 equals negative 19. I said v minus 12. I know the opposite of subtracting 12 would be to add 12. And again, whatever I do to one side, I do to the other. My negative 12 plus 12, well, that makes 0. My goal is to get variable by itself. Well, if I get rid of the numbers, all I'm left with is my variable v. And then again, I'd go over to my Desmos calculator and put negative 19 plus 12 in, and you should get negative 7. And then same thing, let me just grab this other one. Oop, I can't, I'm gonna have to do it on the right side there. Sorry about that. But I'll make sure it doesn't get in this little watermark that's on my screen. So again, I have negative 8 equals x minus 3. Break it into a left side and a right side. Locate that variable x. What's being done to x? It's being subtracted by 3. X minus 3. So I know that the opposite of minus 3 is to add 3. The 3's will cancel out, leave me with my variable all by itself, which is always my goal in an equation in inequality. And then in my calculator, I would do negative 8 plus 3 and get negative 5. So again, make sure you have those in your notes. Again, at this point, I would pause the video. If you need one more example, go ahead and watch it, but definitely get those other 3 on your own. So this should only take you about 5 minutes. If it's taking you longer, you need to move on so that you can get into your assignment. So pause the video now, give a couple of them a try, unpause the video, make sure you got the right answers. And if you have any questions, raise your hand so I can help. So here are those ones. I need to make a little bit of room because I have big handwriting. So let me drop this guy down a little bit and drop this one down a little bit. All right, here we go. So top left. Again, the first thing I want to do is break my equation into a left side and a right side and find my variable. It's on the right side. What's being done to x? Well, it's being subtracted by a 15. The opposite of subtracting 15 is to add 15. Negative 12 plus 15 is positive 3, so 3 is equal to x. The next one we had n minus 7, so broke it into a left side, right side. There's my variable. What's being done to my variable? It's being subtracted by 7. I know the opposite of subtracting 7 would be to add 7. We get n by itself, and then 11 plus 7 in my calculator would say positive 18. And then my last two examples down on the bottom. B minus 1.25 is equal to negative 3.75. Again, I broke it into a left side, right side. I find my variable. I do my inverse operation to minus 1.25. That would be to add each side by 1.25. And then I would go in my Desmos calculator and do negative 3.75 plus 1.25. And my calculator would say negative 2.5. And then finally, my last example, again, b plus 9 equals negative 19. Break it into a left side, right side, locate that variable b. What's being done to that variable? It's being added by 9. So the inverse or opposite would be to subtract 9 to get the 9 to go away. Negative 19 minus 9 in a calculator would be equal to negative 28. Final answer. So at this point, you should have a pretty firm understanding. That should have only taken you about 20-25 minutes to get your notes and your warm-up and everything done. So that should leave you with about 20 or 25 minutes to do today's work. So today's bit.ly is up in the left-hand screen. It is bit.ly/7 capital E equations with the number 1. There is also a circle or 2 problem on there, and also 2 angle problems or a couple angle problems on there. So I put they're just definitions for the angle. So I put what a complementary angle is, what it looks like and what it equals. Same thing with supplementary. And then I also listed your two formulas for your circles. So at this point, go ahead and do your assignment on a separate sheet of paper to turn into me, because remember, I'm going to come by, take a look at your warm-up, your work, and this assignment to be graded for today.